Review of equations. Remember, the main idea here was to get the variable by itself using the inverse operation. The inverse of add is subtract, the inverse of subtract is add, the inverse of divide is multiply, and multiply is divide. So when I look at question 1, I've skipped around. There's a variety of questions here. I'm dividing by -8. To get rid of division by -8, I would multiply by -8. So I'm going to multiply each side by -8, like so. And the 8's cancel, and I get C is 2 times -8 is -16. Question 2. I don't like those fractions. I want to get rid of them. That fraction is really a divided by 2. So to get rid of division by 2, I'm going to multiply by 2. There are other ways to do this, by the way, that even are quicker, but I think this works in every situation, including what we see later. That's why I'm teaching it this way. So I multiplied by 2 to cancel, and I'm left with -5x equals -80. And I've got times here. The inverse of times is divide, so I'm going to divide by -5. And z equals -80 divided by -5. Two negatives, when you divide, make a positive. And that would be 16, I believe. Yes. Question 3. This looks a little like what we did just earlier. I need to get rid of division by 7. There are 3 terms here. There's a term, there's a term, and there's a term. So I'm going to multiply everything by 7 to get rid of that division by 7. 7's cancel. It's n plus 6 is left. Don't forget to multiply by 7. Minus 56 equals -21. This can be simplified. I can combine like terms. 6 minus 56 is -50. And now I can get the n by itself. The goal is to get the variable by itself by adding 50 to both sides. So n would be 29, I believe. Question 5. Look how quick this is. This is a short one. You'll have some just like this on the test. I need to combine like terms. 7 and 6 makes 13. So this is 13 plus x. Now I can get x by itself. All I have to do is take off that 13. And 8 minus 13 is -5. So x is -5. Here we've got more variety. We've got some with variables on both sides, more simplification, and more fractions to eliminate. So question 7, I need to get rid of division by -9. So I'm going to multiply each term by -9. Don't forget both sides, each term. Here they cancel. That's n plus -18 or -18, however you want to write it. And -3 times -9 is +27. Now I can add 18 to both sides to get n by itself. And 27 plus 18, I believe, is 45. Question 8. Simplify. Whenever possible, simplify. A dead giveaway that you have simplification is when you have 1, 2, 3 terms. If there are 3 terms, there's got to be something you can combine. And here, -5x plus 3x can be simplified to -2x. If you don't simplify, you're going to get confused. So we'll add 2 to both sides. That's the first step. The last step is always eliminate the coefficient. That's the number in front of the variable. So we added 2 to both sides. Now I can eliminate that coefficient. Get rid of the -2 by dividing. Generally, that's your last step. -10 divided by -2 is +5. Question 11 has distributive property as well as variables on both sides. I'm going to take -10 to both. -10 times x, hey, that's -10x. -10 times -6 is 2 negatives, make a positive, that's +60. At this point, often I see students try to eliminate one of these numbers, the 60 or the 2, the constant, but you're much better off eliminating the variables. Get rid of one of your variables. In this case, you could either add 10x or add 12x, but I'd probably add 12x because I like to keep things positive. Negative 10 plus positive 12 is positive 2x. But you could have added negative 10x to both sides. That would actually add 10x to both sides. That would work fine. And now eliminate the coefficient last. Let's get rid of the 60. We're getting the variable by itself. 2x would equal negative 58. And I'll divide by 2. And x will be negative 29. Question 12 looks a lot like one we did just a little bit ago. I need to get rid of division by 11, so I'm going to multiply everything by 11. The 11s cancel. Negative 5x plus 1 plus 44 equals 55. I'm going to simplify. Negative 5x plus 45 equals 55. Eliminate the coefficient last. Get rid of that 45. Let's take a 45 off each side. Negative 5x equals 10. And divide by negative 5 and run out of room. And x will be negative 2. Question 14. I need to get the fraction, eliminate the fraction by multiplying by 2. Since there's division by 2, I'm going to multiply by 2. The 2's cancel. I get 8x minus 6 plus 10x equals 30. See how there are 3 terms? 1, 2, 3. That means we can simplify. There are like terms there. 8x and 10x make 18x. Get rid of the coefficient last. Let's get rid of the 6 first then. 18x will equal 36. And we get a nice answer here because we'll divide to get rid of that 18. And x will be 2. 17 and 18. These just take a couple of seconds. On 17, you distribute negative 5 times x, negative 5 times 4. And notice how the variable part is the same, exactly the same. So this and this are the same number, but they have different things added to them. You can't take the same number and add different things and make them equal. It's not going to happen. Those are not equal. This is a no solution. You can do that if you like. 23, it might be the same. We're going to distribute the 5. 5 times 2x is 10x. 5 times 5 is 25. We're going to distribute the 5 again. Plus 10x plus 20. And then we have a plus 2, and we're going to combine like terms. 10x and 10x make 20x. 20... what did I do here? Oh, that was right. 20x plus 25, 20, and 2 make 47. That term and that term are the exact same thing. I've got different numbers added to them. Again, this is a no solution. Just a reminder, when do you get an infinite solution? An infinite solution occurs when you have like 2x plus 7 equals 2x plus 7. If both sides are exactly the same, that is when you end up with all reals, and every number you plug into it makes it work. And the WOM app is having us put the infinity symbol. Okay, so remember that that's a possibility too. If they end up exactly the same, any number you plug in works in it, and the answer is all reals, or they're infinite solutions.
The last question here is the toughest. And the reason for that is because there are two fractions. So I've got to somehow eliminate 10 and 2. I need to pick a number that would cancel with both of those, and that number is the least common multiple. You also note as the common denominator. So what you do is you take your two numbers, 10 and 2, and think of multiples, 10, 20, 30, 40, and so on, and 2, 4, 6, 8, 10, and notice that 10 is the least common multiple. The least common multiple, or common denominator, is the smallest number that both will divide into evenly. Notice that if I take 10 into 10, it goes once, and if I take 2 into 10, it goes 5 times. So both the denominators, 2 and 10, divide evenly into 10, and that's what has to happen. So what you're going to do to eliminate fractions is multiply both sides by 10. This side by 10 and this side by 10. However, here, because there's that subtraction, there are two terms. This fraction bar makes that one term, but I've also got to distribute and take the 10 to the other term, 10 times 2. Now these 10's cancel. 10 divided by 10 is 1, so 1 times anything is itself. So this is 7z minus 4, that's the top, minus, I multiplied everything by 10, 2 times 10 is 20, equals 2, goes into 10 5 times. Now I have to multiply 5 times negative 1, so that's negative 5. And I almost forgot the z, negative 5z. Notice there are three terms over here. 1, 2, 3, separated by subtractions. And since there are three terms, I can combine like terms. That would be the 4 and the 20. So minus 4 minus 20 is minus 24. 7z minus 24 equals negative 5z. There are variables on both sides, and the goal here is to get all the variables on one side and the numbers on the other. So I'm going to take off a 7z off each side. Doing that, I'll have the 24 on one side and the negative 12z on the other. And now all I need to do to get the z by itself is to divide. So I'll divide both sides by negative 12. And negative 24 divided by negative 12 is positive 2. So z is positive 2.